Just want to make sure that I'm actually recording here. Okay, so today we are going to talk about lists. And believe me that this is something different. It will look and feel like everything else because programming languages are written to make things kind of feel natural to you, but it is actually very different than everything else we have seen. So lists are the first containers, and I will try to explain to you the difference, but this is now going to become one of the things that will give you amazing power. You have to use that power wisely. We will talk about how that is, right? With great power comes great responsibility. But it is going to make things very interesting and very, very fun. But you have to understand how they work. So, very much like tuples, lists are a way of storing multiple values. And you store multiple values in a single list, like a container. And the way that you format the list is with a square bracket. That is the Python convention. Different languages may have different conventions, and the way they are implemented are different. But the thing that we care is that list is basically a sequence of values, like this one. Okay. So what this is telling me is that I have a variable called scores, and scores is going to store this list of values. So scores has a value, but the value itself has components. These components are basically numbers. Or you could have values that are strings. So I don't use planets because I cannot really memorize them. So we are going to do animals. So tell me some animals. I have cat, dog.
Platypus.
What? Tell me things I can type. Panda, dolphin. All right, I'm doing those. All right, parakeet. I think I can do that. Platypus. All right. Is this correct? Parakeet. I also always put pig because my neighbor has a super noisy pig that they just would not get rid of. Okay? So the point of lists is that you have lists of values, and these values, technically can be anything, but logically they have to have something in common because you are putting them in a list. So lists are kind of, bags of values that you decide to put inside, and the nice thing about them is that you can use them as a whole. You can look at all the animals, or you can look at one at a time. So you can access an individual one. So for example, if I wanted to find the first animal, I have to address it by 0. So the first animal will actually be 0. So this is kind of similar to tuples, right? But I will tell you why it's different, but let's first do this and then show the differences. Okay? So if I wanted to find the first score, I can use 0. So let me try to explain the scheme. So whenever you have a list, like animals, this was not doing it yesterday, whereas of course it's doing it today. I tested this yesterday. Yesterday this was fine. Of course. My dreams of a good computing environment has not been fulfilled. I was just doing myself so great. So basically, every single element in the list has an index. And the index starts at 0. And this is actually common to all programming languages except for MATLAB. MATLAB will start at 1, just to be annoying. So that means the 0th animal is cat. And this one is 1. And this one is 2. What is the third animal? There is no third animal, right? So if you wanted to read animal 3, it will say, no, there is no such thing. And you can actually in Python count forward and backwards. So first we will learn how to count forward, and then we will go backwards also. So this indexing is true for almost all data types. And we will see that it will be useful in many different ones. So think of this as kind of a new thing, because the variable animals is this whole thing. But the container gives you access to individual elements also. And to get to those, you actually have to give that index. So, animals of 0 is cat, dog, panda. Which one is pig? So tell me what is the index for pig. What is the index for pig? 6, right? So we hope. Okay. Let's see. Can you actually store different kinds of values in a list? Sure. So you can have panda 5 true. The list can really store any number of things, except that when you're programming, you're using it to store some specific thing, so it makes sense to be able to do it this way. So let's try, for example, a simple question. Okay? Write a little list that contains 5 names. Okay? I want you to get used to the square bracket, and then we will get really fancy very quickly. Okay? So create a variable called names with 5 values in it. Okay, were you able to do that? 5 names? Okay. Now, let's find 5 names. Okay. So I'm going to have 5 names. So I have May, Sky, Colson. Who else do we have? Is there a Morse? Fitz, thank you. All right. Thank God. All right. My TV shows are coming back. Okay. So tell me the index of the first value in scores that is greater than 65. So the first value in scores Greater than 65. What is the index of it? So it is 68. What is the index? So 0, 1, 2, 3, 4, right? Okay. Now here's another interesting question. What about the middle value in the list? What is the index of the middle value in the list? So, for example, in scores I have 0, 1, 2, 3, 4, 5, 6 values. Which one is the middle value? This one, right? So I have 6 values. What is the middle value? No, there are 7 values, and the middle value's index is 3. Well, can you do this for any number of values in a list? One of the first things we learn is that given a list, you can find its index in its length. So the length works exactly like in a string, except that for a list, it just tells you the number of elements in it. Okay? So the middle value in scores happens to be 0, 1, 2, 3. So 7 divided by 3 is 2. So the middle value is actually the length of scores divided by 2 plus 1. Right? No, that's it. All right. So let's try and test this. Okay? So we want to find the middle value of a list. So I'm going to try it for 2 different lists. And the way that I would like to try it is I would like to have one list that is odd length and one list that is even length. So the middle value for y is should be what? 3, okay? So what is the index of it, right? So I'm going to take the length of y, which is 5, divided by 2, which will give me 2. So in fact, the 2 is this element because it starts at 0. So I can do this. Okay. What about for x? What is the middle value for x? What is the value? What is the middle value for x? Is 2 the middle value? Is 3 the middle value? You just generally take 2 and 3 and find the half, right? All right. So in that case, the middle value actually is much more complicated, right? So we want to have a separate problem, right? If it is even, if length is odd, we can use this one. If length is even, then we have to use a separate one. So in that case, the IDX middle length of x divided by 2. So it will give you 2. 2 is this value now, right? So again, the length is 4. 4 divided by 2, integer division is 2. But in fact, what I need to do is do this. So how can I tell a number is odd and even? Mod 2 is 0, right? All right, so we are going to complete this when I go back and do some more, learn how to use lists and functions. But we will go back to that one. Okay, so that's kind of enough for simple things. So far, so good. One of the nice things about lists is that you can actually go backwards and forwards. So instead of going from 0, you can actually go backwards. So in that case, the last element is actually -1. So this is a Python thing, it's very convenient. The last element is -1. The second element is -2. And the first element is -3. Okay? So if you think about it, the list itself, so my list has actually 3 elements, right? So if I was counting forward, it started from 0, 1, and up to length -1, right? So the length is 3, so I go up to length -1. If you're going backwards, you have -1, -2, up to negative the length of the string. So whatever the length of it is, it's the same value. So, oh, I lost my animals. Cat, dog, parakeet, panda, platypus. Okay. Oh, forgot the pig. Oh, that pig I cannot get rid of. So, I have 6 animals in here, so I know that animals of 0, animals of 1, all of these are valid up to animals of 5, right? Animals of 6 does not exist because there is no such thing. So positive goes that far. I can also go backwards. So this is the last value, -2, and I can go up to -6. In the negative, since you start at 1, it goes up to the length. What happens -7? It says there is no such thing, right? So it counts in either way, and however you want. Okay. Now, the thing is that so far, as it turns out, this is identical to anything that you can do to a list, you can do also to a tuple or a string. Because in fact, if I had a name like this, we know that you can find the length of strings. You can also find the first element in a string in almost the same way. In fact, what is the last characters in index? 6, right? So, and there is no 7 in the index. In fact, I can probably go backwards in the same exact way up to this. So I can go in the string and index the individual characters in the string in the same way I do with a list. And the same thing is true for a tuple. Because I can, in fact, go up this way or this way. So this is by design because you want the programming language wants you to be able to program easily, so they all kind of work the same way. But it's also why it's confusing because these 3 things are not like each other. Okay? So you can actually index the individual characters in a string as well as you do in a tuple or in a list. Okay? But what is really interesting in a list is that you can actually change a value inside a list. So, for example, instead of cat, what animal do I want? Dog. We already have a dog. But you can actually have a second dog for the koala. All right. I actually saw this Craig's ad for a koala that was so horrible that the owner wanted to give away. It was like the nastiest animal ever. He thought it would be cool, but apparently it was not. So this is what's new, that in fact, not only you can address individual elements in a list, you can actually change the value at a certain location. And you cannot do that in anything else we have seen so far. So you cannot take, for example, we had name. You cannot say name of 0 should be lowercase s. You cannot do this for a string. You cannot do this for a tuple. So you cannot change a value in a tuple. But you can for a list. Okay? So the main difference between all of that is that strings and tuples are simple values, whereas lists are what we call containers. So if you want to imagine what they look like, nope, still nothing going on there. Think of this as follows. So we have 3 variables. So now consider that in your computer somewhere this whole information is stored, right? So basically think of your computer as like a little bookshelf, right? And basically each variable that you have has a place in a bookshelf. So for example, one of them was name. It has, let's say, one bookshelf, and in it you store symbols. And you actually had another one that was values. In it you store multiple values. Maybe it takes multiple bookshelves. So you have 1, 2, 3, and maybe the 4 is here. Okay? For as far as you care, this is not that important. Okay? So you have a bookshelf for each of these variables. But for animals, things are a little different. In the bookshelf for animals, you don't actually store the animals. You actually store where the animals are stored. Okay? For the purposes of this class, you don't have to understand this point of indirection, but I want you to kind of understand that it's a different animal, right? Lists are, containers are very different because in here you actually say, go to shelf something, which will basically be the address of the first animal, let's say cat, or no, we made it koala. And then this one value, the next one is in this shelf, it was dog. And so forth. Okay? It is just that one is a simple value, the other one is a complex value that basically has the value of the variable itself is not the value, but it's actually a location of where it's stored. Because that's why we are calling it a container, because its value is what the things, where the thing is stored, not the actual value. And these are the only things that we can actually change. So, this is going to be very, very important because it leads to a lot of confusion, because they all look the same, they all have the same functions, very similar functions, except lists are really very different. So, you actually have the same type of functions that you have for different variables. So, for example, given a list of scores, let me get back these scores here. You can actually find their min, their max. You can find their sum. You can find the length. Okay. So these are the same functions. You can count in the same way we could count in a string. So you can count how many 63s there are. Okay, I made a bad thing there. Yeah, I don't know how to change that though. Does it allow me to go there? All right. What was I trying to do? Count, thank you. Okay. But here's something slightly different. Okay. So remember, this is the same notation for a string. So you have a string and a function, or a function that returns a new number. right? So this is like the count in strings. This is the same as in, other things. But you also have functions like sort that work on a list, that change the list, but don't really return anything. The only function that we have seen that does this was what? Paste, right? When you do image paste, it changes the image, but it doesn't return anything. This is actually by design, because what if you have a massive list? You have thousands of values. Every time you actually need to change the values in it, if it returns you 1,000 value, it will actually be very, very slow. This is why, actually, when I watch a badly made Hollywood movie, and they have all this stuff they are printing when they're searching for fingerprint, right? They keep showing you all the fingerprints is matching. Why would you do that? That will totally slow down your program, right? You would never output things that unless you really need to see them. So regardless, many functions, you don't want them to output or return lots of things because that could be very slow. So in fact, scores is one of them. The sort is one of them. So sort will actually change the list and sort the values and then return nothing. So think of this as follows. So this is like you basically had scores, right? Scores is stored in that shelf. And then you basically told the sort algorithm, you said, okay, here is the key. Take this key, go to my house and tidy it up. Okay? And then I will come and see how it looks. Right? So it's not going to bring the house to you. It's going to go into your house, sort it out, and when you come in, it's clean and, pizza is ordered, everything is great. But it actually returns nothing. Okay? So we will see more and more functions that do one of these different things. And we need to know what they are. So for example, length is a function that takes a list, returns a number. Count is a function that operates on a list and returns a number. Whereas sort is a function that operates on a list but returns nothing. So if you don't do this right, you can do stuff like this. This is the most common thing that I will see you do. Okay? What will happen if you do this? So now you have to get used to this because this is what you need to do to debug when you do the same thing. What will happen? Okay, so let's do this slowly. So, scores.sort. Sort is a function that applies to this variable. It takes the variable, changes its value, right? So each function has stuff that it does. And in this case, this function can do whatever it needs to do without returning anything. We have not figured out how to do that, but next Thursday we will actually start writing functions that do this. So what it does, right? Well, when the function finishes, what does it return? Nothing, right? Because when you do this, if it returns something, you would see it here. For example, when you did length scores, it returned 7, right? Here, scores.sort didn't return anything. So if I were to then say scores is equal to scores.sort, then what would happen? Scores equals nothing, right? You basically kind of erase your own good work, right? So this is the most common thing. How many of you did this when you were doing images? Oh, come on, you have to admit there's more of you. All right, so this is common, right? It's because, some people will say that Python should not do this because this is kind of confusing, and many people will agree with you, but every language has these weird idiosyncratic things, right? So you have to get used to it because it is never going to be ideal for you. So now scores is not even a list, it is nothing. If I were to say print scores, it will be none. if I were to say, let's go back to scores here. If I were to say print scores.sort, what would that be? It would be nothing, right? Now, interestingly, scores is still sorted because it did whatever the function did, but then it tried to print what the function returns, which happens to be nothing. Okay? So this is where things kind of get more interesting because you have to start thinking about when you're writing something, whether it actually changes the function it works on and whether you want that or not. So, I already have this here. Okay? So let's write a little program here. Find and print the average of top 10, let's see, of values in a list except for the lowest two values. Okay. This is something that I see a lot, so we are going to talk about this. So I give you a set of values. These are, let's say, your running times, or your exercise times, something like that. And each one is kind of a duration. And you have been doing well, except for a few days that you kind of were tired. So you want to see what is the average of, my exercise time. And one day you were working really hard. Okay, so I want to find the average of, the average time you do, but I want to drop the lowest two. Okay, did we drop the lowest in one of the homeworks? Did we do that? I don't know if I had that homework this week. Okay, so basically, your instinct is to find the lowest value and remove it from the list, right? But you really don't need to do that. All you have to do is you have to remove it from the sum of the values, right? So, for example, if I drop the lowest, first I need to find the sum. Remember, don't call it sum because sum is actually a function. Okay, so the sum is whatever, 358. But I want to remove from the sum the lowest value. How can I do that? From this I can subtract the minimum value, right? If I'm just doing the first one. So if I remove the first one, all I can do is I can just add everything and remove the smallest one. Some of you may object to this on the accounts of it is very, what's the word? Inefficient. Okay. We'll talk about that later in the semester. It's still okay, it's order of n. And then I want to divide this by the number of values in the list. So what will I divide this by? How many values in the list? Length of runtime minus 1 because I actually removed one value. Is this going to be correct? Because? That's right, integer division, right? So you should convert one of them to a float. So I'm going to convert that to a float. Okay, so okay, does that look okay? So I took the value, I found the total, I dropped the lowest value, so now I have, all but the lowest. How do I drop the lowest two? So now I want to drop the lowest two. While you're thinking, I'm going to actually format this to be a little nicer. how do I drop the lowest two now? Now you have to use the functions that are given to you. So if I sort it, then the lowest two values are going to be at index 0 and 1, right? Because generally when you sort something, I can actually never remember which way it sorts, so I always check. Okay, it sorts from lowest to highest. You can actually make it sort in the reverse. So, you can actually say, sort in the reverse. But, that's not important right now. Okay, so now let's do that. So let's take runtime. And then, from runtime, drop the lowest two. Think about this, and then I will write this down. So I'm going to drop from this the lowest two. And then I'm going to change this to -2 because I have actually two values. Okay, things are looking better for me. So what if you didn't have two values actually in the list? What will happen? What if you only exercise one day? So instead of this, you only had this value. What would happen? It will give an error. It says index out of range. And it will tell you which line it is in, right? You have to start paying attention to these. In line 7, where you're accessing 0 and 1. Because there is no 1. There is a 0, but there is no 1. So in fact, we are going to start writing programs that don't necessarily fail when you have bad input. So we can actually do a little better. So we can say if, what is the condition that I want to use here? I want to do all of this computation if that's right. So I heard it in multiple places. So if there are at least two elements. So if length of runtime is at least 2 or more, I can do this, right? What else should I do otherwise? I don't have two things to drop, right? So I should probably just not care. I should just basically probably return you the average of everything. So I am going to take the sum of runtime, and then I am going to return, and I'm not going to drop anything, and then I'm going to do this. Okay? So this is one of the things that now we have to start getting used to, is thinking about how our program is going to work and whether it will fail on a certain input. If so, you actually should have an if statement for that. So the next homework, you will see that you will be asked to actually check if you have valid input. And we will see that there are many different functions you can use for that. So, for example, if you have a string, can you convert a string of A into an integer? No. Can you convert a string of 1? Yes. What you can do is actually you can check if a value contains a digit, if it's a valid integer, for example. So we will see a lot of that. Okay, so now let's do a little bit more. Things are going to get much more interesting right now. So one of the things that I want is to change the list. Okay, so far you have a list. You create a list. You can change a single element in it. But what I want is actually to change the values in a list. So first thing we will learn is you can add a new value by append. So you can add a new value to a list by a function called append. And you describe what value it is. So what animal? Turtle. I also heard hawk. I'm going to do hawk the next time. Okay. So it will append at the very end. Okay. So if you are still awake, the append function, does it return anything? Does it return anything? No. So you should not call it as animals equals to animals append, right? Okay. So let's actually write a simple function here so that we can see. So animals is dog, cat, pig. The pig. So animals dot append turtle. Animals dot append hog. You can also change a single element by inserting it at a location. So that's going to be a little different, because this time you're going to use a function called insert, but you're going to tell exactly where to insert it, right? So you're going to say inserted at location 2, and what was the last one? I had turtle and hog. What? Third. All right. I'm sorry. My hearing is not super great. Okay. So where do you expect that it is inserted at? So 0, 1, 2, right? It's inserted at location 2, right? So pig was at location 2. It's now at location 2. Be aware that, this doesn't work, of course, if you do it the other way, right? If you do it like this, it doesn't work because it has to be index value, not value index. Okay? So the other thing that we can do is we can remove information from it. Okay? So I can take animals and I can pop the last value in it. Okay? So the last value in the list is pig, right? So this function is different because this function actually returns you the value. So this is the most difficult one that we have seen so far. This function modifies the list it works on, plus it returns you a value. Right? So in fact, I can say that A is equal to animals.pop. So now two things are going to happen. You're going to take the list, you're going to remove something, and then you're going to take the value that it is popping out and assign it to variable A. So now I have created a new variable A with the value bird, right? So A is now bird, and animals actually now has two values. Okay? So these will take a little bit of time. You have to continuously play with them to get comfortable. So this is the third one. So I can continue adding to this. Okay. So the last one is even more tricky. So let's do this with the scores. So I'm going to have scores of 1, 2, 3, 4, 5, 1, 2, 8, and 10. Okay. So in score, I can also remove, but I'm not going to remove from a certain location. I'm going to remove a certain value. Okay. So I told it to remove 1, but there were 2 1s in the list. So what it did is it removed the first one. Does it return anything? No. So what if I do this again? It will now remove the second one. Okay. What if I do this the third time? Okay. Not only it doesn't remove something, but it actually gives you an error. Okay. Which is actually a problem. You want to actually avoid doing this because you don't want to remove something unless it is already in it. So how could you find if it was in the list already or not? We've learned one way to do that already, which is count. You can count something. So if I have score, I could find how many zeros there are. You can also do another thing that we will see. You can check if a value is in a list or not. So let's write a very simple program, and then we will go here, right? So I'm going to do So I'm going to read some animals that I want to remove, and then I'm going to remove the animal A, and then I'm going to print the animals now as animals. And I'm going to put some more animals here so we can actually remove things, so like panda, parakeet, turtle, nobody gave squirrel, which is sad, or chipmunk, right? Anything that eats my crops. So, okay, so I have all these animals, and I want to remove which animal? Cat. Okay. That worked out fine. If I wanted to remove hawk, is hawk in here? Yep. What happened? Interestingly, it actually did not crash, even though there is a big error here. In fact, it kind of stopped here and then stopped talking, which is very interesting. I don't think that it should have done that. It should have just given me an error. Okay. You see, it's kind of giving me this weird error here, but it's not doing anything. I'm not sure what that's about. It really should, in fact, give me an error. So let's make sure that this actually does not happen. That I am going to check if the animal that I entered is already in my list. If A is in animals, okay, or you can do if animals.count A is greater than 0. I am going to remove the animal and do this. Else, I'm going to print this animal is not in my list. Okay. At least it's not doing that, but it really should give an error. So when you do this, does it give you an error, or it also kind of crashes strangely? It really should give an error. I don't know what's happening. So we are going to be using if statements quite a lot in all of this. All right. So the last thing that I want to do is, so how about what if I want to check, what if I want my program to always work, even if I enter it in uppercase or lowercase? So like, for example, if I enter cat, it's not going to work, even though there is a cat in the list. Do it? So if my list is all lowercase, then what I should do is do it lowercase first, right? So what I can do is I can actually search it like this. Okay, cat works, but bird doesn't work. But regardless of how I entered, I'm actually displaying it in lowercase. So these are the kinds of things that I'm going to torture you with the next time. Okay, so all of that is now very fine, and this is very simple. Okay, but in fact, you can have arbitrarily complex lists in lists. So in addition to having a list that stores simple values, you can also have lists that stores values as well as other things like other lists. So, for example, you can have a list that has, let's use a new one here. So, for example, you can have a list that has a list of businesses. This is the next lab. Whereas each list itself is actually has information about the name of a business, and the phone number. And this is actually the right phone number. Whereas what is your business of choice? Do you have another food place in mind? I knew it was going to be Moe's. I knew it. What is the phone number for Moe's? All right. All right, so now this list called businesses, how many elements does it have? How many elements are in businesses, the list businesses? Two, right? So if I wanted to print businesses 0, and businesses 1, each one itself is actually another list. So business 0 itself is a list that has how many elements? 2, right? So business 0 itself is a list, and the first element in it is actually this, right? So since it's a list, now I'm basically taking that list, applying the same logic. And in fact, I can also play like this. I can even nicely print this. I can say the first string, and then put the phone number in a parentheses, like this. Same as this one. Now what do I want to do here? Business 1 of 0. Two minutes. Yeah. Okay. So not only lists can store information, but lists can store any number of other lists. But you have to start becoming very, very familiar of what they do. Because now you have to know what data type you do have and how many elements there are, and then print them. Yes?
Is there a way
don't think so. There's generally a print function for lists, but for this one, it's just with square brackets. You can actually write your print function, but I don't think that there is one that is specifically just for lists. You have to come up with one. And what was the other thing? And then you can actually convert between different data types. So with that, after this, we are going to get into something new that's not in the course notes, because I think these course notes were not very advanced for us. So, for example, you have a tuple data type like this. Okay. So X is a tuple data type. Can I convert a tuple data type to a list? Can I take a list and convert into a tuple? Can I take a string and convert it to a list? What do you think that would do? It's going to convert every single character into a list. Okay. Can I take a list like this, convert it into a string? Not allowed. Okay. So not everything that comes to your mind is actually something you can write as a program. Okay. So you actually have to remember and write. Yes. Okay. So string conversion is actually str, but it doesn't actually create a string that has the individual things converged, but it actually creates a string representation of the list. But you are right, thank you. Okay, so this is kind of the basics on lists. Do you have any questions so far? All right, so then let's do something a little different. And I'm going to start talking about loops, which I was hoping to do, but apparently I went too fast. Hopefully not too fast for you. Are you following me so far? Okay. So the main thing to remember is that lists, tuples, and strings, they all have the same exact method for accessing individual elements, right? So you can always index things from 0 up to a length, or in the negative order. In the strings, the individual things you access are letters. In a tuple is the individual elements in a tuple. In the list, whatever you are storing. What is the main difference between lists and tuples and strings? You can modify lists. You cannot modify tuples. You can modify a whole tuple, but not part of a tuple. You cannot assign a certain value to it. But all of this is kind of useless unless you learn how to actually go through individual elements in a list. Okay, so lists are kind of useless until you learn to iterate through them. Because then things are going to start getting interesting. So remember the lab where you actually had to find the bunny and the fox population? Yeah? And that was kind of a tedious algorithm, right? Because you had to write the same thing over and over. Okay? So the idea was that whatever you needed to do to actually modify the population of bunnies and foxes were very simple. You just had to repeat it for every single year. In fact, let me try to find that program so that we can start from there and then go on. So let's say, bless you. Okay. It was something like this. It's kind of crazy, but I'm going to even make this a little better. So So I'm going to basically compute the next year of bunny and fox population. This is the formula I gave you, right? But to make life simple, I'm going to return both of them. I'm going to return bpop next and fpop next. So I'm going to return the result as what data type? It's a tuple, right? Whenever you have something with a comma, unless you have square brackets, it's always a tuple. In this case, you can also return it as a list, but I don't think it's necessary in this case. Okay? And then I'm going to read the bunny and the fox population. And to make life even easier, I'm going to just set these up. And then I am going to read the next year's bunny population and fox population by calling next year for bpop and fpop. Okay. So get rid of everything else. Okay. So this is really, part one of the lab. Next bunny is not defined. Where's next bunny? Oh, yeah. Okay. And in fact, this is not right. So I'm returning two things from here, so I'm going to read them into two variables, not two strange functions like that. Okay. So I started by 110, I have 40 and 24. So if I wanted to do it for one more year, what I can do is I can say, okay, now let's assume my current population is bpop next, and my current population is fpop next. Now I need to repeat the same exact thing. I need to compute this, and then I need to compute, print that it is the next year, and then print the next value. If I wanted to do it one more year, I would actually have to repeat this part exactly as it is. The only thing that would change is that it's going to be year 4. This is what I was trying to get you all to do. If I wanted to repeat this again, I would do the same. And now it will be year 5. And then I will do it again. And now it will be year 6. So does it reach an equilibrium? Yes, right? It kind of oscillates between these two values. So the thing that's really more interesting in this case is that this code is identical, right? I'm just repeating the same code over and over and over, right? Take the last value, put it in the current value, repeat the same thing again. So why would you have to cut and paste? The whole reason we write programs is so that we automate things that are tedious, okay? The computers are not our masters, we are their masters, right? They serve us. So if I wanted to actually write code that repeats itself, what we need to do is write what's called a loop. So loops, if you have not seen them, okay, at first sound kind of complex, but in fact, once you get used to them, they are super convenient. Now, if you have seen loops before, a word of caution, for loops in Python are actually kind of confusing. In other languages, for loops are the most useful things because they are simple to write, but I find them very confusing. So because of that, we are going to start with a while loop where we control everything, and then we are going to move from there to other things. So I just want to write a piece of code that repeats a number of times. So to be able to do that, I need to write basically a loop. So a loop basically has 3 parts. It has a part that has a condition as when you should stop doing the same part of the code. So for example, so it will be something like while condition. So this part will repeat until the condition becomes false. So repeat until the condition becomes false. So for example, while let's say, let's start with a simple number. I is equal to 0, while I is less than 3, I'm going to do something. I'm going to print I. Okay? So basically, the while loop, the while condition is when you should continue repeating something and when you should stop. So while the condition is true, in this case, I is less than 3, I will repeat everything that is in the body, so which is kind of indented under the loop. So while I is less than 3, I'm going to print I. Now, in the while loop, though, it's kind of tricky because you have to make sure that I eventually becomes less than 3. Is I becoming less than? Is I is going to become greater than 3? Okay, so let's ask this question. Okay, so initially I is 0, and while I is less than 3, so is initially I is less than 3? Yes? Okay. So I'm going to print I. So I'm going to print 0. Anything else happening? No. In that case, I'm going to go back to the beginning of the same loop, and I'm going to repeat this again. So this is how the loop generally works. So you have while a condition is true. Execute this block. And then go back to this part and check again if that condition is still true. If it is still true, execute this block again. And do this until this becomes false. But in the while loop, it is your job to make it false. So very often, the easiest way we can think of that is use a number. So it starts at 0, but I want it to be eventually greater than or equal to 3. So what I should do is I should increment it. Okay? So while I is less than 3, print the value of I, then increment it by 1. Go back and check if it is still less than 3. So initially it's 0, then it will be 1, then it will be 2, and when it is 3, it's going to stop. Okay? If I had not put this here, would it ever stop? No. And this is something everybody has done, right? So we call this, it's starting to get bored. It says, okay, I'm just omitting some stuff, all right? If you were to submit a program that has an infinite loop to the homework server, eventually it will kill your program, but it takes a while. So you will see some interesting stuff, okay? But even though you wrote it like this, it's not guaranteed that you actually were so smart. Okay? So how about I wrote this condition wrong? So how about this one? So I start I at 1. Is it greater than 0? Yes, right? So I print it, I increment it. Is it greater than 0? Yes. Is it ever going to be not greater than 0? Because I'm going up, right? I should be going down if you want it to be eventually become like this. This is more interesting because now it's like increasing and increasing, but it will never stop. Okay? So remember that when you write a loop, your first job is to make sure that you actually write your loop correctly. But once you do write your loop correctly, okay, somewhere in here, I have the code for the bunnies and foxes. Somewhere. What happened to my bunnies and foxes? There we go. Okay? So what we could have done is we could have done the same thing. Let's say I wanted to actually compute this for 10 years. Instead of like copy and pasting my code, I could have just written a simple thing. Initially, my year is what? So I've computed year 1 and year 2, right? So year is actually 2. And I want to compute this up to year is 10, right? So while year is less than 10, I am going to compute this. And I am going to increment the year by 1. And in fact, this is going to be now the year counter that I already have. So I can just put the year here. And I can put bunny here and fox here. Right? So now I've actually cut this. If I wanted to compute this for 100 years, all I need to do is change that one character, right? So the loops give you a lot of ability to change and repeat the same thing, but you have to be very responsible. So on Monday, we are going to see loops to do all sorts of interesting things because lists will become interesting, but I want you to be at least comfortable doing a simple counting loop, and then we'll go from there.